When the USS John F. Kennedy stood out from the pier at Newport News on August 12, 2026, she carried a promise forged in a very specific, very brutal piece of arithmetic. To secure the funding for this ship, the Navy had to legally commit to an 18% cut in labor hours compared to the first ship of the class, which ran severely over budget and arrived years late. Government auditors called a cut of that magnitude unprecedented, requiring a massive shift in how the yard managed its workforce. They were betting on a manufacturing law called the learning curve. It was first plotted right here on the floors of 1930s aircraft plants. This chart shows the core math. As you double the total number of units built along the horizontal axis, the labor hours required for each unit drop by a fixed percentage. Workers naturally gain speed through repetition. It is the physics of habit. The second time you weld a 10-inch steel plate, you do it faster than the first. By the 10th time, you do it by feel. But there is a dark clause in that law. The learning lives in the hands of the people doing the work, not in digital blueprints or computer drives. If you stop the production line, the learning does not pause. It is erased. Engineers refer to this decay of human skill as going cold. Right now, the American shipbuilding line is freezing. A gap in manufacturing orders is wiping out decades of accumulated industrial memory. Losing this workforce memory is the core of the $2 trillion cold line, a crisis that forces the Navy to relearn how to build the very machines that define its reach. To see the cold line in the real world, look at what the Kennedy left behind at the pier. Newport News is the only yard in America capable of building and refueling a nuclear carrier. It operates as a single, narrow point of failure. While the Kennedy headed out for trials, that waterfront was choking. Parked nearby is the USS John C. Stennis, a failure sitting 14 months behind schedule on its midlife overhaul. The delay comes down to a shortage of the one asset you cannot 3D print: certified hands. There are a finite number of nuclear-certified welders in the world, and training them takes decades. This creates a structural logjam engineers call the synchronization gap. Back in 2005, the Navy laid the steel for the Ford-class hull. At that moment, builders had to make final, permanent decisions about pipe placements and bulkhead thickness, a state known as the frozen baseline. At that exact time, the F-35C stealth fighter meant to launch from the ship was still just a drawing. The Navy used a strategy called concurrency, building the physical ship while waiting for the aviation technology to be finished. They bet the two pieces would snap together perfectly. Instead, locking in a multi-billion-dollar hull design for a jet they had never flown created a trap for the shipyard. The physical reality of the F-35C was a shock to the steel. The jet's engines run 700 degrees hotter than the ship was originally designed to handle. Look at this cross-section of the flight deck. When a pilot kicks in the afterburner, a 3,600-degree exhaust plume hits the steel. At 2,000 degrees, structural steel gets as soft as clay. You cannot launch a 30-ton jet from a deck that is rippling. The Navy had to perform orthopedic surgery on the hull. They cut out steel to install a vascular network of pipes, pumping cold seawater directly under the deck to absorb that heat. Standard paint explodes into shrapnel under that heat. Instead, they had to switch to a ceramic metallic skin that is blasted onto the deck at supersonic speeds. Every one of these fixes added hours. The Kennedy's delivery date walked from 2018 to 2020 to 2025 and finally to 2027. That 10-year gap between the first and second ship is the signature of a line that lost its momentum. A carrier requires a supply chain of 2,000 specialized manufacturers. When orders stall for a decade, these shops don't just wait, they close. And when a sole source supplier goes out of business, the Navy has to spend years qualifying a new shop to handle nuclear-grade materials. The heat of the Navy's new stealth fighter didn't just impact the flight deck, it broke the rhythm of the entire American shipbuilding industrial base. To save the supply chain, the Navy attempted a radical intervention, a block-buy contract, to purchase two carriers at the same time, the Enterprise and the Doris Miller. This gives small suppliers a steady rhythm of work. It allows them to outrun inflation and prevents certified hands from leaving for the commercial airline or tech sectors. But there is an irony in this innovation. The top timeline shows the old Nimitz class, which must return halfway through its life for a 5-year refueling overhaul. The bottom timeline shows the new Ford class, designed with a reactor core that lasts for the entire 50-year life of the hull. Because these new ships will never return for that massive midlife maintenance, the shipyard is being stripped of a major source of future work. The Navy is spending the yard's current capacity to build a ship that will never return to give the yard work tomorrow. The trials of the Kennedy were an audit of a superpower's industrial memory, a check to see if we still have the ability to execute the complex coordination required to build these machines. The real weapon isn't the steel carrier itself, which can be bought, but the unbroken generational habit of building it. We are spending billions to keep these skills alive in a world shifting towards drones and AI. In that context, is a 50-year nuclear carrier still the right investment, or is it a legacy choice the next war has already bypassed? The contracts have been signed and the schedule set. But the actual resilience of the fleet is decided by the raw human element, the specialized, scorched hands of the welders.